Boom. Hello and welcome back to Calculus 1 Exam 1 review. So you might be wondering what's on the exam, and there will be questions, right? So what do we have? We have chapters 1 and 2. So from chapter 1 we are looking at definition of the function, we're looking at the graphing, well, that's, you know, all the shifting and stuff. We're looking at the function composition, and we are looking at the inverse. These are the important components that we are going to use in calculus, obviously. And then we have the chapter 2. Now, for chapter 2, we have limits, and that's it, right? Now, remember that limits are solved by plug-in. If that doesn't work, can you do algebra? And if that doesn't work, can you do the graph or a chart? Yes. So the one at the end is 100% of the time works, but it's a lot of labor and work, and we don't, right? We keep it as a last resort to look at the graphs and charts and so on. So if we can't plug in, we go through algebra. Now algebra has the canceling and the factoring and the rationalizing and all of the different types of witchcraft that you can apply to get this done. Now we also have limits, infinite limits. What is the purpose? What was the application? Infinite limits. Anyone? Infinite limits.
Well, graph is vertical.
Vertical asymptote, yes. And then we have what? Limits at infinity. What is this one? Yes. There's also Squeeze Theorem. Well, think of the one-sided limits also.
Is there going to be anything on the slant asymptote?
Is this a request?
No.
If it's a request, just let me know. I mean, we are all in the business of making you know, happy and satisfied customers, you know. So you want the slant asymptote? Problem on a slant asymptote. Not a problem. We good? We good? All right. So then we have the Squeeze Theorem. I don't know if it requires its own thing. Squeeze Theorem is just one of the limits. It's not a concept. What else is a concept? Continuity is a concept. Continuity is a concept, and the last is the definition of the limit. Limit definition. I'll just put epsilon delta so you know what it is. That's the exam. I hope you're not disappointed.
How many questions is it?
Enough. 10 to 12.
Okay.
Unless you are requiring
No, it's always good.
more or less. Make a one question exam. 100%. And you say, oh, I just didn't study that particular one. I studied everything else.
My life story.
It's your life story. Well, here's the gist. If you study calculus, you're definitely going to hit the questions on the exam. I know, right? Okay. What else? That's it. So, state the formula means write the formula, not words, not examples, but the formula. What is the formula for vertical asymptote? To check if number is a line is a vertical asymptote. What is the formula? So formula for vertical asymptote. What are you going to write? If that is a question, say, what would you write? Exactly. So if you know the formula, you clearly can't do anything else. What's the formula? Limit x goes to that value of f of x needs to, yes, plus or minus, good, gives you plus or minus infinity. Or limit x goes to a minus f of x is equal one of the infinities. So if this is true, then VA at x equals a. If you get the non-infinity, right, so you get whatever number, then it's the open circle. It's not a vertical asymptote. So this is the part of calculus that you're learning definitions and theorems, and that's where it goes. Anything else? Shall we take a look at these problems? Good. The first problem says, if the limit x goes to 4 of f of x is negative 64, find the limit of f of x to the 1/3 as x goes to 4. Well, at one point in this course, we had those limit laws. And the limit law for fractional exponents said that the limit of f of x to whatever exponent you can master over here, as x goes to a, is going to be the limit of f of x, and then everything raised to that exponent. So now when you have 1/3 exponent, what is that? What is the 1/3 exponent?
Cube root.
Cube root. So, to solve this problem, we say limit x goes to 4 of the cube root of
64.
negative 64. No, sorry, negative, just f of x. We don't know what the f of x is. So now we use the rule that gives us the square root outside, and now you have f of x. So now this is the cube root of 64, negative 64, which is negative 4. And that's the problem. So we are allowed to, we rewrite this problem using the cube root, and then, yeah. Ta-da! That's it. Questions, concerns? All right, good. Yes.
How do you know when that as opposed to 4 factor into it?
Doesn't.
It doesn't, right? Alright.
Good approach to anything. It just means that there's a 4, negative 4 is a point. Graph, yes.
And on the test, you want to show all that work, right?
If you have negative 4 at the end, it's negative 4 at the end. But if that says negative 5 and there is no work, how much partial credit is due?
There.
How much?
0.
0. There we go. This looks cool. Give an example of functions f and g such that limit of f of x is 0 as x goes to 1, and limit of f of x times g of x is equal to 5 as x goes to 1. So this is definitely from one of those vertical asymptote problems, because if denominator if you can factor and cancel denominator, then we're good to go. So you have functions to consider here. They gave you the functions. You just need to pick the correct one. Now, what do we know? From functions that they gave us over there, the capital A, capital B, capital C, capital D, we have, now maybe, let me write them all. So f of x is given as x minus 1, and g of x is given as 5 over x squared minus 1. B, f of x is equal to x plus 1, and g of x is equal to 5 x squared minus 1. C, f of x is equal to x plus 1, and g of x is 5 over x minus 1. And finally D, f of x is x minus 1, and g of x is equal to 5 over x minus 1. Give an example of functions f and g such that the limit of f of x is 0. Now, limit of f of x is 0. I hope you see that when you take the limit of f of x as x goes to 1 and you're aiming for the 0, I hope that you see that that eliminates what letters immediately? B and C. Good. Because the limit over here, when you plug in, and this is a basic function, so no denominators or anything like that, if you're just looking at f of x, when you have f of x and you need to go to 0, well, 1 minus 1 is 0, 1 plus 1 is 2, 1 plus 1 is 2, and 1 minus 1 is 0. So that eliminates B and C immediately. Now we need to construct the function. Limit of, let's use the first one, so it's x minus 1 times 5 over x minus 2. X squared minus 1. There we go. As x goes to 1. Now we can cancel these, right, and work it out. So we have the limit x goes to 1 of 5x minus 1, that's in the numerator. And in the denominator we have x minus 1, x plus 1. When these guys cancel, and you plug in 1, you get 5 halves. Well, that's not really 5 that they were looking for, because in the statement of the problem they say they want the multiplication to give you 5, not 5/2. So this is us trying part A, and it didn't work. Let's try part D. So we have the limit x goes to 1 of x minus 1 times 5 over x minus 1. And I hope you see these guys cancel, and you're left with 5. So that's that. So it's part D. Did it make any sense? Yeah, good. It's math, right? So we tried, right? We tried A and we tried D to calculate to see what values we are going to get as we compute this. All right, next one. So we have find constants B and C in the polynomial. P of x is equal to x squared plus, they should say bx plus c, right? This is supposed to be an x over here. Such that,
Yes, that's right. Sorry.
so this is x.
Yeah.
Limit x goes to 6 of p of x over x minus 6 is equal to 13. What a wonderful example. Maybe we should put like 10 of these. No one? Really? So one person. Yeah, whatever. Bring it on. All right, so if I plug in this polynomial, I have limit x goes to 6 of x squared plus bx plus c divided by x minus 6, and I need that to be 13. Now, what is the issue here? The issue is that we have to make it so the polynomial we are looking for has x minus 6 in it, so it can cancel. Because if you are approaching 6 and you have x minus 6 in the denominator, once you plug that in, it's going to give us vertical asymptote. But we are not looking for vertical asymptote, we are looking for a point. So, so what we are going to do is we are going to try and make, I don't know why I did that, try to see if we can get x squared plus bx plus c to factor into x minus 6 times x and then something over here. And then we also need to make sure that this part over here is equal to 13, because that would be the surviving term when x minus 6 cancels. So this part over here also needs to be equal to 13 when x is equal to 6. So that's what we have. All right, so how would we do this? Well, we just use, dare I say simply, we use the polynomial division. X minus 6 divided into x squared plus bx plus c. It goes x times, multiply back, we get x squared minus 6x, and then you subtract, it's a standard division. These die, and we have b plus 6 times x, and then we drop down c. So what is the next? X goes into this one, plus b plus 6 times. Just a standard division of polynomials. Multiply it back. You get b plus 6 x minus 6b minus 36. So when you subtract, these guys go away, and what you're left with is the c plus 6b plus 36. That's the leftover. So what do we have? We have the x squared plus bx plus c equal to x minus 6 times x plus b plus 6 plus c plus cb plus 36 over x minus 6. So that's the factorization. And now, what do I need? I need this thing over here to be equal to 13. And I also need something else. What else do I need? So now what I have limit x goes to 6. We have x minus 6 here and x minus 6 in the denominator. They cancel, and what's left is x plus b plus 6 plus, and this fraction c plus cb plus 36 divided by x minus 6. Hello and welcome back to Calculus 1 Exam 1 Review Part 2. Because the stream died at some point. Alright, so what are we doing in this problem? We are trying to find the constants b and c so that we can actually have the limit go to 6. Now, limit go to 13. So the way we do this is, if you look at the first line I wrote, right, we plug in p of x where it goes, set all of this equal to 13, and now what I need is I need to find the division, right, use the long division to find factors of the polynomial, trinomial. And I do that by the, dare I say, simple long division. We can actually do synthetic division as well to verify this. So synthetic division would be 6 into coefficients, and the coefficients are 1, b, and c. Those are the coefficients and for this division. So you bring 1 down, and then 1 times 6 is 6, so you get your b plus 6. And then when you multiply these, you get your b plus 6. And then when you add them, no, you multiply 6 times this, so it's 6b plus 36. There we go, much better. And now when you add these guys, you get c plus 6b plus 36. So it is correct. Yeah, what we had before. So now I write this as a product. The only issue is that I still have x minus 6 on this end.
It was a little different before. Yeah. You have c plus cb. Now you have c plus 6b.
Oh, I wrote it wrong here. Okay, thank you. Well, you write C and you write 6, so yeah. Good. What happened? So this is a 6b. Sounds good. Said no coffee. All right, so what else? So now this x, oh, I see. Hold on. I wrote this wrong. That's the issue. There is a parenthesis over here and then plus. So parenthesis over here and then the plus, so they don't cancel. Much better. It's a remainder. So when you are multiplying these two, you have to multiply the factors and then add the remainder to it. I had it written wrong. That's why. Yes. So now when I do it this way, it makes sense. Okay, so now limit x goes to 6, and this x minus 6 will be for both because there's a plus over here, right? So technically you have two things to worry about. On the first one, it just goes x plus 6 plus b plus 6. And then we have plus another limit, x goes to 6 of c plus 6b plus 36 divided by x minus 6 squared. And these two are equal to 13. And I don't like this at all. So when I plug in 6 on the first one for x, from this one, when I plug in x goes to 6, I get b plus 12. Right? The problem is that I can't plug in here because it's still in denominator and creates 0 in denominator. Where is the issue? X squared plus bx plus c equals 13. We take this one, so it's x minus 6 times x plus b plus 6, everything plus c plus b 36 over x minus 6. I'm not sure.
Number 51.
So technically I should just put this on a test, someone will solve it and I don't have to worry about it. Then I can just look. Alright, so far we have this plus the limit of x goes to 6 of c plus 6 b plus 36 over x minus 6 everything squared is equal to 13. And when you subtract 12 on both sides, we have b plus the limit, c plus 6b plus 36 over x minus 6 squared is equal to 1. And the limit is x goes to 6. Huh. So I hope you see why we have to force our polynomial to have a factor of x minus 6. It has to have a factor of x minus 6 because that will cancel x minus 6. Are you sure you copied all of the numbers and everything?
You can scroll around and see. There's a little bit of...
Yeah.
Now I wish I copied everything. Actually, I don't know if they gave the solution. That's why I asked you. They only gave that top part.
They went a little bit different, but
Which one was? For the last problem? The one that we did?
yeah, they're defining the y, which is
The other two sense, like, either plus or minus, it doesn't say which one it is.
Yeah, how do you estimate this?
Yeah,
it doesn't make sense.
Oh, if you're going, then you can't get it.
Okay. This is a really cool problem.
Oh, I didn't know.
All right, guys, I'll have to meditate on this question. So how many of these should I put on a test?
None. I mean, if you can solve that, then you should do it. I don't mind.
If you want to put extra.
Oh, you're gonna remember all that, right?
No, just put it
All right, so I'll think about this and figure out the solution. Yeah, I'll figure it out and then we'll talk about it again.
Is it bothering you?
No, actually, this is really cool because it gives you the purpose to figure out the solution. This is it's very rare to run into these kind of things in calculus courses. So I finally got to think since the beginning of the semester, which is cool. So this is what we call the late night tonight. Yeah.
No.
What happened with the dinner?
I said your wife's gonna be like, Nick, come to dinner, and you'll be like, no, not till you solve the problem.
Exactly. I have enough reserves to skip a few of those until this is addressed. It's only in terms of x's. No? Yeah, I'll find it. I'll figure it out. Let's see if you have anything else. That was a cool one.
Oh, can you go back to the last one? I wasn't done with
What?
I'm on the screen. I wasn't done writing the last part of that last problem.
This stuff?
No, down. The last problem. Yeah. Okay, so you're right there.
But apparently it doesn't work this way, so I'll have to figure out. I'm getting x minus 6 squared in denominator, and that's, again, when you plug in 6, it goes to 0. So there has to be something else. Does anyone else have any other question, or we're done with the review?
Can you give us some questions, examples that you think I can know?
No, this is where you ask questions. I ask questions on Thursday. Today you ask questions.
Can you give us some examples to solve it?
Yeah, which ones? Tell me.
Can you do a squeeze, one of the squeeze theories?
Yeah, which one? Today is about your questions. Thursday is about mine. We swap the roles. Yeah, they're looking for it. I'm only solving the stuff that you give me today. When you run out of stuff to solve, then it's done. Any luck?
Should we just write it on the board? Does it matter what?
Whatever problems. If you have nothing, then you guys can go enjoy your lab. It's okay.
You want to write all the...
No, just put it over here. I'll take it. What does it say? Oh, beautiful. Let me just copy it for a second. So we have a piecewise function, x squared minus 8x, and ax cubed minus 9. And this is the if x is less equal than -1 and if x is larger than 1.
-1.
-1, that's what I said, please pay attention. Determine value of a. So what's a equal to, so that we have the determine a value of a constant a for which limit exists. So we need to make sure that the limit x goes to -1 of g of x exists. All right, thank you.
Yep.
Well, in theory, for limits, we know that if you have a piecewise function, it is okay to have a piecewise function as long as the two ends meet on the same height, because limit computes the y values. So this is me not solving the problem yet. This is me just talking about theory that surrounds this. So if you have a piecewise function, let's say you have a piece that goes like that, and then it stops, and then you have another piece that, let's say, go flat. Doesn't matter. So this is a piecewise function, and the limit is here. So this is okay. Let's put a over here. So limit of f of x exists as x goes to a. Limit as x goes to a exists. Now if you have a piecewise function here and it does this thing, limit does not exist at a. So your job is to figure out what number goes here for this a, so that you have these two pieces of function lock up at the same point, and then the limit exists. Now if you look at the left, it's the y value for the left side, and if you look from the right, it's the y value from the right side, and they have to be the same. So we immediately see that x squared minus 8x needs to be the same as ax cubed minus 9. And all of this is happening at x equals -1, because that's the value. So all I need to do is to solve this equation. Now x equals -1, we plug that everywhere. So I have -1 squared minus 8 times -1 is equal to 8 times -1 cubed minus 9. So this is 1 plus 8 is equal to a times -1, so negative a, minus 9. 1 plus 8 is 9, and 9 from the other side says that negative a is equal to 18, so a is -18. So if a is equal to -18, we have a limit, because that would guarantee that the y value for the first piece of the function and the y value for the second piece of the function end up, as you can see, the equal sign in between, ends up at the same height.
How did you switch? -a minus 1 and became -a plus 1.
No, this is a minus here. It's a minus. You copy it, and then when you move it to the other side, it becomes plus 9. So 9 plus 9 is 18. If it's going to make you feel better, 18 equals negative a. There we go. So a is negative 18. Anything else? I have no clue how would you do problem part without understanding the...
She thought the graphs pertained to the column.
Yeah, yeah.
Concept-wise, they do.
Yeah,
Like that I have to do that.
realistically, no.
Mm-hmm.
I don't have to do that.
Because the book, this thing is telling you to plug in -1 for x squared minus 8x, find that answer, plug it into ax to the third minus 9, and it just doesn't make sense. But
Because it's disconnected from the concept. That's the reason why it doesn't make sense. Once you understand, right, we have the theorem which says that the limit x approaches a minus of f of x needs to be the same as the limit x approaches a plus of f of x. So that's the left limit and the right limit.
yeah.
Now, this technically says that the y value is equal to the y value. And now, what happens is here, the y values are the same for the left limit and the right limit. So that's why this would hold, because they're the same, and then there is over a limit. In the other case over here, you get this value here and this value here. So you have y1 and the y2, and they are not the same. And that breaks the theorem from left and right and over a limit. So that's actually what solves the problem, that theory, which is why you're setting these equal to each other and trying to make sure that they, on the height, they meet. All right, any other questions, concerns? What's the problem? There was definitely no dinner yet. There's definitely no dinner yet for you, right? Because I can barely hear you. What did you say, limit?
Limit tangent x.
Ooh, tangent.
Yeah.
Limit tangent x.
X approaches pi over 2.
Good. Okay. So now, this is one of those problems that you actually can't do without graph. And even if you do the chart, it's going to be bad. So we know, hopefully, that graph of the tangent has vertical asymptotes, and then it looks like a cubic, and then has more vertical asymptotes, and then looks like a cubic, and it's going to do that forever. Now, the first time it goes through 0, and then there is a pi over 2, and then pi, and then 3 pi over 2, and it's going to do the same thing forever, 2 pi. So tangent is going to go forever in this fashion. Now it says, what's happening for the tangent x as it approaches pi over 2 from the right? Well, approach pi over 2 from the right is this. So you see that you are going down this line. So the answer is negative infinity. Good. The answer is negative infinity because when it approaches from the left, it falls down to infinity. Sorry, from the right, it falls down. If you approach from the left, it will be positive infinity because it goes up the line. So it's, you're looking at it, you have the left hand and right hand. So approach from the left means coming in from this side, and approach from the right goes in from this side. So approaching from the left, from the right. So it's right, and then it's coming at you from the right. Anything else?
Formal definition of the limit.
Formal definition of the limit. So, limit as x goes to a of f of x equals L. So what's happening here? The definition says for every epsilon larger than 0, there exists delta larger than 0 such that the difference of f of x minus L is less than epsilon whenever 0 less than x minus a less than delta. So this is the statement, and the meaning of the statement is those tubes that we talked about. So we have some kind of a function f of x, and then somewhere we have this value a which you are approaching, which is supposed to produce limit L. Now for every epsilon that you pick, no matter how small, so you pick an epsilon to be some value like 0.003, even though we're not solving problems for this. So the bottom line is L minus epsilon, the top is L plus epsilon. Now you see that they have the values on x-axis as well. Now the one on the left is a minus delta, and the one on the right is a plus delta. So these epsilon and delta actually create these tubes around a, which leads towards L. So as you squeeze the tube around a, and this is what does the squeezing over here, this part, because you are, what is x? X is every and any and every, right, point. So you can think of this point as x, but it's not fixed. That's why it's x. It's a variable. It is going to take on all of the possible values that it can on its way towards a. So this is where x lives, and this is also where x lives. So x is the one that it's moving. That's why we say x goes to a. A is fixed, right? You will say x goes to 3. We know where the number 3 is on the number line. It's a fixed location. So when you say x goes to a or x goes to 3, you are going to that location. Now it has to be a point somewhere that it's going towards the 3, or in our case a over here. So that's what does the squeeze, this part here, because x minus a is trying to be smaller and smaller and smaller and smaller, because this epsilon and delta are extremely small quantities. So as you squeeze over here, you get a squeeze on y, which is less than epsilon over here. So that's the secret of this. You just squeeze on the x-axis, it will squeeze the y. If you squeeze the y, it will squeeze the x.
And the delta is just some arbitrary value you pick, and from there, that's like the starting.
Well, it's actually, it says for every epsilon there exists delta. So it's epsilon that you pick, and delta is what's calculated. Again, we're not doing the problems for this at the honors Calc 1, but yeah, you will say I want epsilon to be 0.000000001, right? And then your job is to go to the proof and calculate what would delta require to be in order to have that epsilon. And if you find out that delta is a very, very small number, then that's good. So these numbers have to be small. Squeeze one, the other one has to be small. Otherwise, if you squeeze, let's say squeeze here, and your y's grow apart, that means that you have the limit does not exist.
Most of the calculations that we're doing is starting with the x and getting the y. That's the opposite.
Yes. That's completely opposite, yes. For every epsilon, because you are making sure that there is the answer to the whole thing. So that's why you start and say, okay, let L exist, and let me make a little neighborhood around that L, and see by the intermediate value theory. Remember how you have those two numbers and so on. So all of these things play the role in the proofs and understanding the deepest concept. Any other questions, concerns regarding the exam? I'm stressing? Why am I stressing? Yeah, so you just come in and show off and leave. It's simple as that. Should be happy for the opportunity to do that. Anything else?
Transformations.
Transformation, yes.
You just review the horizontal shift, the fifth example.
So the shifts in from pre-Calculus1, section 1.6 in a Chili Pepper book, they're used generally to deal with the problems where you can't find the limit by algebra or plugging things in, and you want to go and use the graph. And we did a lot of those problems in vertical asymptote. If you go to vertical asymptote, I had those little graphs on the side. So that's where it was shifted left, shifted right, and so on. Now, generally what we need is the reflections on x-axis, reflection on y-axis. Those are very frequent. And the stretches, not so much. You know, the vertical, horizontal stretch, they are not really the central part of our, I mean, they do show up here and there, but it's not as important as shifts and reflections. So stretching and shrinking. What's happening over there? One-sided limit. Okay, so one-sided limits always exist, right? That's the rule. You cannot have does not exist for one-sided limit. So that's the first part that we need to know. And then if you can't compute by hand, like by plugging in the limit, then you would have to look at the graph. For instance, you are looking at the ln x function, right? You're looking at ln x function. It has the vertical asymptote at x equals 0, which is y-axis. You can come up with a chart of values, and you would see that the values are really shooting towards negative infinity. So now we're going to see a good example of it. Here. Okay. Good. So the question on the board, let's what happened? What's wrong with text?
I don't know.
It's a what do you call it? A cabriolet textbook. It's cool. So evaluate limit of square root of x minus 2, x goes to 2 plus. This means from the right. Well, we are going to graph this function. I mean, you can plug in 2 and you will get 0. Right? If you plug in 2, you will get 0. So equals to 0 simply by 2 minus 2 equals 0. But we have to be very careful with these one-sided limits. Well, let's see. So let's graph square root of x minus 2. Square root of x is a basic function which graphs this way. Are we all agreeing on this? Beautiful. So square root of x minus 2 is shift right 2. Now observe that you can approach 2 from the right, but you can't approach it from the left. Do we all see that?
Yeah. So
There is nothing to there is nothing to walk on to get to 2 from the left. There is only, see, if I am to now remove this, this is the function. Don't worry about axes. Axes are nothing to do with your function. The graph is actually just this line. The x-axis, y-axis, that's for our, for us to orient ourselves. It is not a part of the graph. The graph is just the line. Now look at this line. This line will go to infinity on the right. So you can approach 2 from the right because you can literally walk on this all the way down to 2. So you can approach from the right, but you cannot approach from the left because there is nothing there to walk on. Think of it that way. So now I'm going to put my axis back and get the dude off. So now, if I approach from the right, you see that if you are walking on this thing, you will end up at elevation 0 because the answer for the limit is the y value that you compute. So we are getting a 0. Now the same question, limit square root of x minus 2, where x approaches 2 minus, well, that does not exist because there is no function to deal with this. So one-sided limits, when you compute them, they always exist. The issue over here is that you can't compute because, remember, the limits compute at infinitely many points approaching the point of interest. Well, there are no points to compute approaching point of interest because there's no function on that side at all. So it's a little bit settled there, but it hopefully makes sense. So one-sided limit in this case, and I already told you the other example, which was ln x. Yes?
So that was on the exam. You would have to do all that and write the
No, you would just write a paragraph explaining it. It's calculus. Well, I didn't write anything. I was speaking, and it's live.
So we have to write it in a paragraph.
Yes. To explain why you can't approach from the left. You would state this, but then there's the, you know the famous why, right? When someone is 5 or 4.
If you put, you can't walk on it.
I mean, whatever you draw it, whatever you draw the guy, but you can't walk on it because this reason and this.
you just put
That's
the
what it
function's not
says,
defined for that.
technically.
Yeah.
Yeah, function is not
Take the square
defined.
root of a negative number. That's all.
Well, it's not a square root of a negative number. It's just there's no function there. You can't take a square root of a negative number. You get complex value.
There is no function there because.
There is no function there. That's it.
Oh, why? What's the answer? Why? Is it negative?
No, it's just there is no function. All right, let me ask you, what's south of South Pole? Now what you gonna say? See that? And then if you come up with something, I'll just say why. These are you have a function definition. And if you don't like, if that function doesn't fit your application, something else does, right? And that's the end of it. Or I can give you the favorite of my parents, because, and just walk away. See, some of you know what I'm talking about. Why? Because. Can I go outside play? No. Why? Because. That's all the explanation required. Yes?
So the homework, the 3.1 and 3.2, can you make the due date on the Tuesday?
I can do anything. We talked about that. Divine powers. So you want me to add 3.2? Okay, fine. Oh, no? Oh. Oh, okay, I got you. Sure. You're welcome. No, we understand each other. So you clearly said 3.1, 3.2, not on the exam, even though 3.1 is, right? And then, and the extend the homework. Sure, I got it. Anything else? Is that time for the lab now?
Can we go back and look at the quizzes? Like, after they're closed, we can't go in and look, but there was things in there.
Because the same problems that the quizzes are in a study plan. Study plan contains 100% of the problems available in the software, and all the quizzes and homeworks are just sample questions from that pool.
You remember I emailed you about that piecewise function with the postage and it wasn't computing right? I wanted
Yeah.
to try to figure out why.
Probably, well, it's a glitch, so it will still be wrong when you go back and check it. It was, you did it right, so. You did it right.
I saw that come up, well, I guess I redid it again, and I got it right only because I played with the numbers. Like, it gave me different numbers,
Yeah.
but it was still going to give me the wrong answer if I did it the way you say I'm doing it.
Yeah, that was supposed to be it. It's annoying, but just, you know, in the programming glitch, what are you gonna do? Any other questions, concerns before I shut this? And 3, 2, 1, 0, -1, -2. All right, so that's it for the review. I guess you guys can enjoy.